Hello everyone, we're going to work on the last part of 8.3. And this is finding the volume of composite figures. So we're taking everything that we have covered in 8.3 and we're bringing them together, literally. We're going to make composite figures. Composite shapes, composite figures, composite solids, they all mean the same thing. In our case, we're dealing with 3D shapes. Last year you did the same concept only with flat shapes. Composite solids, they are two or more solids combined. So let's look at some examples. A hemisphere and a cone, what would that look like together? Well, let's see. Let's draw a cone. That's the base. And then let's draw our hemisphere right on top, because that hemisphere uses the same radius as that cone. Let's combine a cylinder and a hemisphere. Well, our cylinder is like a can, and then our hemisphere is right on top. And this is actually called a silo, and I'm even going to double check. Make sure I spell it correctly. Yes. And that's typically in test questions, word problems. A silo, usually it holds grain. It's on a farm. So there's your little vocab word of the day. So now let's talk about soup. I have a can of soup here. It is in a cylinder. And with it, I also have a joke for you. Our joke of the day: what did the duck eat for lunch? Soup and quackers. Anyways, so going back to the soup, this is 1 can of soup, and we don't have to do the math on it because they always tell you the volume right here in the corner. If you ever do any cooking and they say you need 15 ounces of soup or beans or chicken broth, this tells you where to find how much is in this can. So this can holds 15 ounces. So I'm actually going to create a problem out of this. Let's pretend I'm trying to create a taller can of chicken noodle soup. So instead of having just 1 can here, let's pretend I'm trying to make a super can, and I'm going to combine 2 of them together. So now at the store, I can go shopping for 1 really tall can. I'm going to glue these 2 cans together, fill them up. How much chicken noodle soup would be in this tall, new size can? Well, let's do the math. Let's create this composite figure of 2 cans of soup. So here's my first can. And then right on top of it, I'm going to go ahead and glue a second can right on top. So we have a composite figure here. We have one shape right on top of the other. So we have 15 ounces, and since this is volume, it's cubed. And then we're going to add 15 at the bottom as well. So we have the top and the bottom together, 30 ounces cubed. So that is the volume of the composite figure. If you need to pause the video here, go ahead and do so. Copy that down. Now let's tackle a new shape. So I wrote on here Tinkercad to remind myself to mention it. Tinkercad is a really cool application, and I'm pretty sure you guys have access to at least the basics on Tinkercad through the Westminster School District. If you don't, that's okay. I'm going to do a little example on just showing you some basics with it. It's kind of a cool program. It's for 3D printing, but if you're a visual person and my flat shapes don't make sense to you, Tinkercad is going to be a little more of a visual thing. So let's go ahead and find the volume of this composite figure. So if you notice, we have a cylinder on the bottom and a cone on the top. And let's throw in our information. We need, let's say our height here is 9 feet. And our radius, we'll say, is 3 feet. And then we've got a height of our cone. Let's make the height of the cone 5 feet. So this has two things. We have to find the volume of the cone and then add it to the volume of the cylinder. We're basically just adding two different shapes together. If you need to copy that down, go ahead and pause your video here. Let's go ahead and review the volume of a cone. Volume of the cone, I'll use a different color just so we keep things separate here. Volume of the cone, remember, is 1/3 pi r squared times the height. And the volume of the cylinder is pi r squared times the height. And remember, height. So height of the cylinder is different than our height of the cone. You notice the radius, though, is the same. Make note of that. Radius is the same. So let's go ahead and do the math. You're going to need a calculator for this. Volume of the cone. Remember, 1/3 is like dividing by 3. Pi times our radius, which is 3, squared times our height of the cone, which is 5. And what does that give us? One-third pi times 9 times 5. Plugging that into your calculator. 47. We'll round 0.1. So there's for the cone. That would be feet cubed. Now let's add it to this cylinder. Which is going to be pi r squared height. Our height of this one was 9. Which is 254.5 for the cylinder. So we're going to add these two together. And when you do, you should get 301.6, and in this case, it's feet cubed. In this case, excuse me, feet cubed. Now I'm going to have you guys try one on your own. Let's do a cylinder, and I'm drawing it on its side here with two hemispheres. So one on the side and one on the side. So it's kind of like a capsule. And let's make our we're going to say 8 feet long for the cylinder, and let's make it a radius of 2. Radius of 2. So if this is a radius of 2, that means the height is also 2. But that's also 2. But I don't think you need to worry about that. Okay, so go ahead and try finding the volume of that one. And you're done.